you want me to cut it open and pin it first?
Let's just do the whole process.
Okay.
So we're dissecting a male wandering garter snake, Thamnophis elegans. We're going to remove all the organs so that we can look at them, look at their chemical composition.
You have to be very careful to pull the skin upwards, especially in the mid-region, so you don't nick the gallbladder. This snake was rapidly decapitated humanely, and so it does not have a head, and then it was frozen and thawed. Just cutting the ventral side from the neck all the way down to the cloaca. So as you begin to pin back the neck region, you can see the trachea right here, and it has it's just a long tube, and you can also see the ribs that run down the entire snake. You can also begin to see the esophagus, which is a long, opaque white tube that also runs from the neck. In the neck region, the first organ that you will encounter is this white mass. It, on first glance, looks like a fat body. However, it's actually the immune organ of the thymus in the snake. And we are removing all of the organs, so we just carefully remove this organ. And again, here's the trachea, and here's the esophagus right here. Directly underneath the thymus and before the heart, which is right here, is the thyroid gland, which is right here. It's a ball. And that is often clear to sort of a yellowish color. We're going to actually leave the thyroid in for now. The heart is sort of it can vary from a very dark red to kind of this lighter red. Oh, thank you. Depending on how much blood has been lost during the euthanizing of the snake. This snake, since it was decapitated, has already lost blood during that event, so it's a lighter pink color. And we remove that as well. Next, you will come into the lung, and in snakes there's really only one functional lung, and you can see this lung has been opened slightly, and you can see all of the surface area. It almost looks like a sponge in here, and I'll kind of cut it open. It's very delicate and very difficult to remove, so we actually leave the lung in for this experiment. But you can see all the surface area in this lung. And again, snakes really only have one lung, one functional lung. And the lung runs from right here, right around where the heart is, all the way to down into the region of the mid-liver, which is the next organ, which is right here. Let's pin back that. And you can jump in anytime if you want to add anything, Andrew.
Looking good.
The liver is incredibly long in snakes and is the largest organ that you can remove. And you can see that there is a lot of just clear connective tissue that needs to be removed. But all this entire white line here, that is all the esophagus leading to the stomach, which is further down. So you can see underneath the liver here, if I can remove the liver without cracking it, there's actually some air in this lung, which is kind of cool to see. You kind of almost peel back the liver, and as I'm pulling the liver, you can see the lung is connected to it right here, and you can kind of see all of those pockets where air can collect in the lung. Again, this is all lung below here. And as you can see, especially in this organ, snake organs are extremely elongated. And the liver is an excellent example of that. The liver color varies from kind of a darker red to kind of this brownish red color. And at the end of the liver, you start to get into the stomach and the gastrointestinal tract. And you also start to get into fat bodies, which can sometimes make dissections more of a headache than anything. And they're also kind of disgusting. Very scientific. One of the cool things about dissecting a snake is that it's very different than dissecting any other vertebrate that you'll ever dissect because of all the elongated organs. So you can see here the esophagus reaches the beginning of the stomach area, and here the fat bodies start. If you can see the difference in color and texture, the fat bodies are a little bit more pink, and they are also, it's very easy to pull them apart. There's almost a translucent quality to them.
And they're actually not connected to anything inside of the body cavity, unlike all of the actual organs, which are held in clear connective tissue known as mesenteries. Fat bodies, if they weren't so slippery, you could easily just pick them up and lift them right out of there.
They're just very difficult to get a good grip on. A lot of times that's the heaviest entity that we pull out of the snake. It's obviously not an organ, but it's the heaviest thing that we do pull out of a snake. So you can see here that the snake, this particular snake has not eaten recently because the stomach is very small, but it's this stomach can stretch to great proportions depending on the size of the meal that the snake is eating.
So one reason for the elongate other organs is that when a prey item takes up such a huge mass, the other organs need to be skinny so that they don't get in the way.
You can see I'm just kind of pulling this fat out because right now I'm entering the region where we will find the gallbladder, the spleen, and the pancreas. And that's going to be, thank you, right below the stomach. And it's often really embedded in fat. So the gallbladder is very easy to burst because it's full of bile. And if you burst it, obviously it's difficult to get an accurate weight. So you have to be very careful. And unfortunately, there's often a lot of fat surrounding it. So I usually, as Andrew mentioned, you can just kind of pull the fat, but I usually try to cut it out a little bit to reduce any sort of strain, especially in this gallbladder area. Right below the fat and right below the gallbladder is the pancreas. So you do want to make sure not to pull too hard or cut into the pancreas. It's a pinker color, which you'll see in just a moment. It's starting to become visible. You want to try to remove the gallbladder quickly though, because it will burst. So before you do too much pulling out of things, that's an important one to get out and to get an accurate weight quickly. It's probably the most difficult one to remove accurately. Hopefully I can do it. Around the area, it's often stained slightly greenish, especially since the snake has been frozen and thawed. And that does not mean that it's burst, it just means that its color has just stained.
A little bit has leaked out.
Yeah. And one of the saving graces is that there's a little bit of connective tissue around the gallbladder, so if you don't cut into that, you're fine. You can see here that the gallbladder is actually connected directly to the other organs through this white tube. So the easiest way to remove the gallbladder is to actually find that connection and very carefully snip it. And then use your tweezers or your forceps to kind of connect it. And just separate it like such. And that was a successful extraction. Right underneath it, as I mentioned before, is the pancreas and spleen. And interestingly enough, these are two very closely associated organs in terms of they're actually connected when you extract them. So you have the stomach continuing and going into the intestines in this area. And so it's connected, it's right up against where the intestines start.
And that's the location of the spleen in most vertebrates because it secretes hormones that go directly into the digestive system, like insulin.
The pancreas.
Pancreas. Well, and because they're connected, they're normally both found.
Yeah.
Right there.
So it's very difficult to tell the difference between the two because they're actually connected. But if you look at the two after I extract it, I don't know, Andrew, if you can...
Yeah, you can see that pretty well still.
Okay. So there's really two different colorations. Just extract some connective tissue. And so you've got kind of a lighter pink down here, and that's the spleen. And then the tip of this, there's sort of it almost looks like a protrusion. That's the pancreas. So this little round area right here, that's the pancreas. So to separate these, we actually find where they connect we simply remove them like such and weigh them separately. There is often a little bit of pancreatic tissue left embedded in the spleen, but it's a negligible amount. Okay, so we've removed all the digestive organs that we removed for this experiment. We start moving into more of the intestines, and of course we have fat. But the next thing that we're going to run into, since this is a male snake, are the testes. And the testes kind of look a little bit like fat and intestine, so you have to be really careful when you're extracting some of this fat to not remove testes with it. And so if you can remember, you can kind of see the little stain of the gallbladder. Right here is the testes, and we're gonna see it in just a moment as soon as I remove some of this fat. So it comes up pretty quickly. Now, one of the other interesting things about snakes is their paired organs that they do have are not next to each other in the body. And Andrew, you can maybe talk a little bit about that, but.
Sure. So far we've only seen unpaired organs, including the lung, which is unpaired in snakes, but the gonads and the kidneys, as well as the adrenal glands, are all paired. And because of the slender cylindrical shape of a snake's body, what you always see is that the right of the two paired organs is anterior to the left. So it can be a little bit difficult to remember which side of the animal is the right versus left when you're dissecting it, because it may not correspond precisely with your right and left. But in this case, you can see Lori is removing fat from around the right testis. It's on the right side of the animal's body because the ventral side of the animal is facing up towards the camera, and it is also located anterior to the left testis, which is actually more than one full testis length behind the right one. So they're not even slightly overlapping. One of them is completely anterior to the other. And you can see that Lori's just exposed the anterior tip of the right kidney behind the right testis there, and then the left kidney will be posterior to that and on the other side of the body.
All right, so just for kind of to reinforce what Andrew was just saying, here's the right testes, and right below it, all the way down here, is just starting to expose the left testes. Mm-hmm. So you can see how
see it well now.
Separated they really are.
So the left testis is in the same place as the right kidney, as
right.
The anterior portion of the right kidney, because the kidneys are longer than the testes. And it's difficult to see, but of course the testes are connected to seminiferous tubules that carry sperm from their place of genesis in the testis to the hemipenes. So that's analogous to the vas deferens in humans, and you can actually see it really well right there, highlighted against the darker color of the kidney. So that's actually the right seminiferous tubule running down from the right testis past the right kidney, even though it is in closer proximity to the left testis, that white stripe on the kidney there.
All right, so as soon as I remove this fat, I will extract the right testes. And as you're removing this, remember that the digestive tract is still running all the way down, and so you've got this white tube, which is the intestine, and so you want to make sure not to remove that with the fat.
And if it's empty, it can be quite hard to find.
Yes.
Although, for the purposes of this experiment, if you cut into it, it's not the end of the world. If you do have a snake that does not have an empty digestive tract, then it might smell pretty terrible if you cut into it. So
it's quite unpleasant.
You want to try to avoid that.
Okay, so I'm gonna come back up here to the right testes, and you can see it resembles a fat body. So if you're not looking for it, it's easy to miss. But what we do is, again, we just very gently separate it from the intestine, which you can see here is this tube right here. It's got it's a little bit pinker than the actual testes. And you have to be very careful on the posterior end because they're almost connected here, and there's a small white kind of granular tube which has a blood vessel running next to it, but right here, and that's actually the adrenal gland. So if you're kind of thinking in order, you have the testes, the adrenal gland, and the kidney. And so you have to be very careful as you're extracting the testes to not extract the adrenal gland alongside that. So when you're looking at that, it might be more difficult to see where the adrenal gland ends and begins, but it's right here. I don't know if that's visible.
Yeah, that looked good.
Okay, good. And just finish pulling that out. And so the adrenal gland is in a slightly different space here than it is in a female snake, because obviously they don't have testes. And so in a female snake, you would actually find the adrenal gland, here's the kidney, you'd actually find it more underneath a kidney, which is more to the dorsal side of the snake. And so it's really more associated with the kidney, because of course the adrenal gland is... In females, right. Yes, sorry. The adrenal gland is very closely associated with salt regulation and that sort of thing, which is obviously important for the kidneys. So again, as you can see the seminiferous tubules running down the kidney, which you would not see in females, obviously.
And as you might see in our next video, which perhaps will highlight the dissection of a female snake, sometimes this region of the body is full of developing follicles. So in addition to all the fat, you also have to deal with removing all of the follicles that are present in the oviduct. So males is actually easier to get to some of these organs.
Yes.
Because the sperm don't take up nearly as much room.
Sperm are cheap.
That's right. You can see Lori's just removing the kidney now, which is quite long, more than twice as long as the testis. And she's still working just on the right side of the animal's body. So being careful not to snip away at that left testis and adrenal gland that's visible right next to the right kidney.
And for the purposes of our weighing, we'll remove this seminiferous tubule after we've removed it from the snake. It makes it a little bit easier. You can almost peel it off.
Just pulling out a little more fat there.
Snakes have a surprising amount of fat in their bodies. I think it's surprising because it's not very quantitative.
Well, as you were saying before, sometimes the mass of all the fat bodies put together can equal or exceed the mass of all the other organs combined. So the liver, testes, kidneys, heart, all together weigh less than the total amount of fat. So for a snake of this size, you might expect to extract 3 or 4 grams of fat, whereas each of the other organs, except for the liver, typically weighs less than 1 gram. Oh gosh, sorry about that.
Do you want to continue to show the extraction of the left side?
I think they've probably got the idea. So those are all the major organs. There might be a little bit more fat left behind down there in the posterior most part of the body cavity. And
the one thing that you can do when a snake has, when a male snake is already deceased, is you are able to take a little bit more close look at the hemipenes, which are the paired sex organs. Here's the cloaca. You can see The seminiferous tubules, they're much larger down here. This is the digestive tract. And you can kind of see some discoloration. There's a little bit of leftover food bits. But in here, this is actually these are the hemipenes, and I'm just doing something called everting the hemipenes. And you can see that in all species have very different hemipene structures, but in this species there are some very interesting spikes on the hemipenes. So the seminiferous tubules actually run directly to here, and this is where the snake will mate with a female.
Good stuff.
Yes.
Thanks, Lori.
Thanks, Andrew.